Hello. Yes, we welcome you back to PSSB, Physical Sciences. Survivability with me, Richard here. Yeah, today we are looking at this case. It says that the four equations of motion are given below. So these are the equations. And they say these describe the quantities of motion for a body with uniform acceleration. Yes, they are restricted, especially the first three are restricted to an object which is moving with uniform acceleration. Yeah, when we come to this case, it says that a car accelerates from rest at 8 meters per second. Okay, and the question says, calculate how far it can move after 4 seconds. So how do you go about this? Okay, when it comes to application of equations of motion, the first step should be to list the variables you have. Okay, let us list them. What do we have? We have the acceleration, which is 8 meters per second squared. Okay, what else do we know? We know the initial velocity. They said from rest, so it is 0 meters per second. Okay, what else do we know? We know the unknown, which we are going to calculate. It is displacement. But we know time. The time is 4 seconds. I remember we have the four equations of motion, and our job here is to choose the right equation which has these variables. The question is, which one is the best equation to use? Yeah, the best equation is, which has all this, is going to be delta x equals to vi delta t plus a half a delta t squared. Yeah, after that, next is to substitute. Okay, what do we have? We are looking for delta x, we don't know it, but we know vi, it's 0. And we know the time, it is 4. Okay, plus a half times acceleration, which is 8, and times our time, but this time around squared. Yeah, from here, we have 0, because any number you multiply with a 0 is 0. Here we have a 64. Yeah, this gives us displacement as 64 meters. Yeah, so that is it. Yeah, now we come to this question. It says that calculate the final velocity after 4 seconds. So how do you go about this? The same steps. We list whatever we have. We know that delta t is 4 seconds. Okay, our unknown is vf. Okay, but we know our acceleration is 8 meters per second squared. And we know our initial velocity is 0. Yeah, we can proceed and even put displacement, but this information is sufficient. We don't need any other information. So from here, what do? We select the right equation. The equation which has delta t, it has vi, vf, and a. Which equation is that one? That one is the first equation, which says that VF is equal to VI plus A delta T. Okay, what do? We do the substitution. We're looking for VF, but VI is known, it's 0, and acceleration is 8, and the time is 4. Okay, giving you 0 plus, yeah, that is it. It's 32. So what do we get here? Our final velocity is going to be 32 meters per second. Yeah, that is it. Yeah, then we come to this question. It says that calculate the time it will take to cover 1 kilometer displacement. Okay, let's check. What do we have here? Yeah, like we said before, the best way to deal with cases which require equations of motion is to list the variables first. Then after listing the variable, you pick the right equation. So what do we have here? We have the acceleration that has not changed, and it is 8 meters per second squared. What else do we know? We know initial velocity. It started from 0, so it's 0 meters per second. We know this time the displacement, 1 kilometer, which is 1,000 meters. We need to be reminded that our displacement, the SI unit is meters. What else do we have? We look for the unknown, the time. Yeah, so we have the data, and next is to pick the right equation. So which equation is having all this information? It is the third equation. It says that delta x is equal to VI delta t plus a half A delta t squared. Yes, the one which has all this. And next we substitute. This one is 1,000. VI is 0, but times the time which we are looking for. Then we have half times 8 times the time we are looking for, but squared. Okay, so what do we get out of this? We are going to be having 1,000 equals to 0, because any number multiplied with a 0 is a 0. Then you have this. This one is going to be 4 delta t squared. So on simplifying, this is what we are going to have. 1,000 is equal to 4 delta t squared. So what do? We get delta t squared by dividing both sides by 4. Okay. So from here, what do we get? We get 250 here, giving us delta t squared. You have to be reminded that we are looking for delta t. So what do? We find the square root of both sides. So we're going to have delta t squared, and we find this square root is equal to 250, and find the square root of that. This one gives us delta t, which is equal to 15.81 seconds. And with that, I would like to thank you for your time. The channel is PSSB, Physical Sciences, Silver Bullet with me, Richard here. We urge you to subscribe, to comment, to like, to share. Yes, we believe we are simply the best. See you next time. Bye-bye.